Hi everybody, today we're going to review the ShineDesign tool from Growatt. It's a PV designing tool for using Growatt inverters. First of all, you have to enter this page, shinedesign.growatt.com. I will put this link below this video. And the next step is to create an account. It's pretty straightforward. In case you want to use PVSys, you can click over here. And for using PVSys, you will require an OND file. In case you need it, you can contact support, but you can also click over here, choose your model, and you will obtain the data that you need for using PVSys along all the instructions. Well, the next step is to log into your account. You have four main tabs: Homepage, My Project, and City Manage and Panel Manage. In Homepage, you can visualize your last projects, your PV models added, and any city that you have added. In My Project, you can visualize all your projects, delete them, or keep designing. In City Manage, we have already many cities worldwide added to our platform, but in case you are missing a city, we are going to review how to add the data in order to keep using the platform. We have also a preloaded PV module list, but in case you're missing any module, we can add it through this tab. Well, the first step in order to create a project is click New Project, and I have already prepared a project for this example, and I have chosen the city of Mérida, Yucatan in Mexico. If you click Optimized Angle, it will choose automatically the optimized angle for this latitude, for this location, but we can change it also manually. You will visualize over here the yield per year, and over here the yield per month. Down below you can choose the PV modules that you want to use. As I said, we have a preloaded module list. I have chosen for this example the Jinko with 400 watts. But what happens if the ShineDesign list doesn't have the model that you want? Well, you only have to go to Panel Manage, and as you can see, I have already created some. It's pretty easy to do this. You have to write the manufacturer and the electrical data of these models. And where do you get these numbers, these values? Well, you have to get the data sheet of the model that you want, and you will find all the details over here, like the temperature coefficients and buck values and all the values that the ShineDesign platform asks. After that, you only click Sure, and you have loaded your model. What happens if we have a city that it is not preloaded in ShineDesign? As I told you, we have many countries, and especially the main cities. For example, in Mexico, of course, we have Mexico City and some other important locations. But if we are missing any, you can create the city or the location that you need for ShineDesign. For this example, I'm going to show you how to obtain data from a city close to Mérida, which is called Valladolid. Oh well, you have to choose the region, the country, the city, which be Valladolid, the altitude, and the coordinates will load automatically when you move this big point. For this data, sun density distribution, it means the yield per month that you have in this particular location. And many customers have asked me how to obtain this data. Well, I usually recommend to use two different sources. Of course, it depends of your needs, but for these examples, I'm going to show you two platforms where you can get the data of any location in the world that you want. This one is Global Solar Atlas, Well, you only have to move the pick point over here and choose the location, and it will give you details of this location. You have to go to direct normal irradiance. Remember to use always irradiance values, not radiation, because it's a bit different. And well, these are the values that you have to load in the ShineDesign platform. Okay, in case you want to use another source, one that I like to use also is the data from NASA. I will put both links below this video, but well, you have to verify that you're using SSE renewable energy, that you have chosen climatology, and here you click pick point again, and well, you choose the location. Please don't change the date. Over here you can choose how the platform will give you the values for this location. And over here you have to go to tilted solar panels. Over here to enter this folder, you double click, and you will need solar irradiance for equator facing tilted surface. You go below submit, and after a few seconds it will give you the data. Oh, well, we can see over here the values for this particular location. Many times solar latitude is the one that is used. Of course, you can choose any other data that you want. You might find helpful to use lower tilt. This will depends only of your design and your final decision as designer. And well, you have over here these values. As you can see, these values are different from the data of Global Solar Atlas, because these are daily average yield values, peak hour zone, as many people call them. And well, what you have to do in order to use these values in ShineDesign is to multiply them by the number of days per each month. And well, after that you only click sure, and you will have your city loaded. Well, let's keep going with the design. For this project I will choose optimized angle, and you have to be careful of the PV module temperatures, because this may affect the limits of the voltage and the number of modules that you will have for your design. You can choose if you want to design your project by the number of modules or the power for your design. For this design I have chosen a Mac inverter, which is commonly used in Mexico, and I will use two inverters. Here there's a rule called REHEL, which is a rule that is mainly used in Germany. So most of the countries won't have this requirement, so please don't click it if you don't need it. This model has 3 MPPTs with 4 strings per MPPT. If I use 15 modules in 2 MPPTs, well, per string, and in my third MPPT I use 14 modules instead, I will be using almost 100% of the power ratio of my inverter. There's a value also called oversizing DC-AC ratio. What it means basically that it is 1 divided by this number. This tool also allows me to calculate the power loss in my cables in the DC and AC side, and at the end it will give me the values for this design. Of course, we have 2 inverters, 2 Mac inverters. We're using basically the system at 100%, and well, this will be an estimated energy yield per year. Let's see now some examples of how the platform will respond to different values of stringing. For example, I will use 21 panels per string, and it will appear as a red mark. Please be aware of any red mark if you modify something, and also be aware of yellow marks. Of course, the red means that something is maybe real bad and you have to be more careful with this. In this case, we are over the voltage limit, so we will try to get a lower value. Some regulations, like in Mexico, doesn't allow to have over 1000 volts over rooftop. We will lower this value to 18 to comply with this rule. Now we have more power than the rated for the inverter. This is called oversizing. Let's push the oversizing a bit more. And now, as you can see, we have a yellow mark, which means that we have to be careful with the oversizing. And it depends of each inverter. For example, for the Mac and Max inverters, we have a DC-AC ratio of 1.5. So we are okay for this design. And finally, you can click print and it will give you a PDF like this one.